talking about Node.js and server-side rendering. It's a topic that it's getting more common, I think. And even though more people start to switch to the edge, but I think most of people still use Node.js for it. So who am I? I'm a software engineer for more than 13 years. And right now I work as a front-end software engineer at OLX Group. And I work specifically on the platform team where we go after things like scaling, search engine optimization, look at the front-end metrics to try to improve it. So that's why we are kind of connected with the team of this talk. So first I would like to present to you how the Node.js event loop works. Probably most of you know how it works, but how Node.js works, and this is why it's so easy to do concurrent things on Node, is everything kind of works in one thread, in a single thread. This is good because we don't face race condition, we don't face things like that. But running everything on the same loop can bump into performance issues. That's why when we talk about high performance, we talk about multiple threads, and Node.js only uses one. But most people probably remember when Node.js came to life, everyone was astonished about the number of concurrent connections it could handle. And that's how the event loop works. Like it doesn't wait for the work to be completed, it just picks up a new work, waits on the queue, and does it over again. Earlier I was saying that it's kind of single-threaded. Right now this is not true. It's multi-threaded. For example, the garbage collector works in a different thread. There are multiple threads internally inside Node.js doing some work. And I won't talk more about like how the internals of Node.js loop works. I will leave these links on the presentation that can show you how everything internally works. So I won't worry. So the next thing I want to talk about, and this is related with the talk, is how CPU-bound work and I/O-bound work inside Node.js. As I was saying, bound implies like a bottleneck. When we're trying to optimize like to the most requests, if we have hundreds of thousands or millions of requests, we need to optimize. And in Node.js, it is non-blocking on AI, but it is blocking on CPU. If we're doing some CPU-heavy stuff, it will block the connections, but the I/O is not bound, and it kind of works like if we go to McDonald's or any other restaurant where you ask in the counter, they will not when we do our order, they will not wait. They will not stop the kitchen and wait for order to be complete to do the next one. So everyone starts to do orders, and McDonald's behaves kind of like Node.js. And this is kind of good, it's single-threaded, and that's why it scaled so well earlier. It's because threads, and this having just one thread is kind of cheap, because talking between threads and between processes, it's very heavy and very intensive, and that's why Node scales very well with I/O. But the issue comes with CPU-bound tasks. Like it starts blocking your server is not able to respond properly, so it starts getting slow and start queuing connections and things like that. And now I would like to present SSR. Probably most of you are familiar with it, but the ones that aren't, like SSR is server-side rendering. It was an old thing, like every one of us did it in the PHP ways. We just rendered everything on the server. But what we do right now is just render what is rendered on the browser, but render it in a fake browser inside, kind of a fake browser inside the server. And as we can imagine, running a fake browser inside the server is like a very heavy thing to do. And this shows that like SSR in Node.js is a CPU-bound task. Like it will hurt your server in the long term. And if you have very complex pages, it will be really slow. So how can we overcome this? Like I will present to you a couple of alternatives. First, like we can rewrite this in Go, Rust, C, or C++. Like all these languages are faster. But the thing is, like we are talking about server-side rendering with modern frameworks that are in JavaScript. And so we need a JavaScript VM to run them. So it's not possible to just rewrite it. And another thing that we can do, it's what most companies do. And for example, it's at OLX, it's what we are doing currently. We just add more pods or more containers. But the issue is, by adding more containers, you are putting, there's a bit of overhead in the container, that you have the overhead of the Node.js, you are replicating that. And managing 10 pods or 10 containers is not the same thing as manage 100 or 500. And that can become an issue. And another thing, and this is a thing, for example, Next.js was developed for, and most of modern front-end frameworks, we can just run it on the edge or use serverless. And with that, we stop the management issues. But sometimes the issue is we need to do integrations with plugins that only work with Node because it's legacy stuff, it's internal stuff. Or sometimes it's very hard to manage, or the infrastructure of your company is not very aligned to it. Sometimes the company just doesn't want to go to the serverless way, or the contract with AWS is not good for doing Lambda at edge. So there's also not a good option. Another thing that we can use, and it's there since the early days, not the first version of Node, but the early versions, is that we can use the Node.js clustering. What this does is runs multiple processes of Node.js and shares the socket between them. The issue here is kind of the same thing that we have with the pods and containers. We just create a new process of Node, so we have all the overhead of the process. But yeah, it's a bit better than more pods. But the other thing, and that's the thing that I want to focus this talk on, is we can use worker threads. They are quite recent or quite old, depends on the way we see it. It's before COVID, so it's quite old. So it launched in the beginning of 2019. And with this, we can just send the work to a different worker thread. But there is way less overhead because we are communicating between threads, it's not between processes, and we don't need to instantiate a new server or a new process of Node. It's in thread inside Node.js, so it's a little bit lightweight, and we have a little bit more control. And how others are doing it, and this is one of the articles that inspired me for this talk, is, for example, Wix applied multi-threading in Node.js, but they only have the article. They don't show you why. They just say, we used React, SSR, and we used worker threads. They don't go too much detail. So it got me curious. For example, as in OLX, we are using Next.js. I was thinking to myself, can we approach this? Can we solve this the same way? And that's what I went to. And to try to implement this in Next.js, the first thing I look at, it's because when you are working with threads, I was saying that threads are cheap, but I was kind of lying because threads are not so cheap. That's why, for example, Golang has green threads that are lightweight. And in the approach that people use for threads is they use a thread pool where you have multiple threads already warmed up, already running, and you send requests to all of them, so you don't need to create threads every time, because creating a thread is OS syscall, operating system syscall, and it's very heavy. And the other thing I ended up using Piscina. It's a thread pool for Node.js. It's one of the most used. I don't know if it's the fastest one, but for the POC I wanted to do, it kind of works. Then I used an API that was created for the web. That is the message channel, because even the worker thread specification goes hand in hand with the service workers on the browser. So it's a good thing. Like, the API is very well documented, and we either in NDN, either in Node.js, so we can do a lot of things with them. And the other thing I used, and it's one thing that is starting to get more used, if you want to integrate like some custom thing, some glue, is a proxy object API, because we need to read something from a private API in Next.js, because the Next.js talks directly to the response, to the HTTP response, and you can send that over threads. Like you need to serialize data to pass them between threads. So we need a way to pick up this data, and Next.js, as of now, doesn't provide a public API for it. So the PCN is something like you can write code like this. You just declare where is your worker. You can say like, I want a minimum of like 4 workers and a maximum of 4. So you have always 4 workers form, and inside of a worker can have any function. It can be a sink. You can even initialize it as sink. I will show you later. For the message channel, it's just a message passing. It's like an event bus, but between threads, and this is kind of useful. And the proxy, it's probably some of you have already used it, is that we can intercept. We can just wrap it around an object, and we can intercept properties and send it to anywhere else. So, and how did we do it? This is on the main thread. First we create like a stream, because one of the things that we tried, and I didn't explain earlier, is that we had to enable in Next.js the streaming, because sending the full page consumes a lot of memory, and it's very intensive. But by using streaming, the memory consumption goes down, and we can process more stuff in parallel. And what we did is first created the stream, and we sent this stream as a response type. We are using Fastify as a server. We could use Express. We could use anything. And inside here, you can see it's the event handler for the channel, and we are just receiving messages. We check for each message. We either push them to the response stream if it's the right message, or we just end it and just finish the stream so we can respond. And in here is when we call it. We just send like the request we needed. For this, we have little thing. We don't have everything on the request because this is just a POC. And then there is a transfer list. It's what copied for the other thread. And we had to wrap it inside of a promise because we need to wait until the message passing ends. And inside the thread, what we do, we just create kind of dummy requests and responses. We wrap the response like with the proxy, and we read for calls. For example, for the end, it's when the send of response finishes from Next.js. It just sends the event end, and there's the get header, has header. Basically, I just did before doing this, I did a proxy where I would console log all the calls that Next.js would do to reverse engineer it. And then this is the second part. It's like just posting messages like write head is status, because status is the API, and Fastify the same. And write is when you are writing to a buffer in Node, we write chunks of data. And the nice thing about this is in the write, in this write, as we have this in an argument, it's what Next.js has down here. It sends a response, and it is serializable into a buffer that gets on the other side. So it's like work done for free for me. And let me go. Yeah, this is the main thread again. It's when we pick up. And when we receive here, like we already received like as a byte array. And when we write it to a response stream, it gets serialized automatically and sent to the browser. So you can check my GitHub. I have all the code there. It's kind of simple. It's not more than like 200 lines of code. And after doing this, I said like I have to benchmark. Like it is really slow, because even though like worker threads are kind of cheap, there's overhead in them. So I tried to have like I created inside a component, a React component, something that blocks the main thread for 1 millisecond. 1 millisecond is configurable, or 10 milliseconds, something like that. And for 1 millisecond, like as you can see here, it is already, it's 1.65 times faster, and having server-side rendering that only blocks for 1 millisecond is quite fast. So, and one thing that surprised me, it was the memory consumption. Like the memory consumption is not 4 times because we are not instantiating everything around Node. We are not creating a new node. We are just creating a worker thread with Next.js there. And even this number is a bit lower. This is the peak that I found the bigger. But usually it's around 250, so it's around 2 times what is in the single-threaded version. So it's quite good. And next, I went to check something. So I didn't block anything and check, let's see if we get improvement from it. We didn't get like a big improvement. It's almost the same as fast, but it's because there is overhead even rendering like a very tiny component, very small component. And then I tried with like 5 milliseconds blocking. It gets 3 times faster. It is able to handle 3 times as the request, and it's almost 4 times faster in the median and 3 times faster in the P95. So it's quite good. And as we increase the number of the blocking time, it scales very well. It couldn't be able to respawn, and even the memory on the single sometimes gets higher because it needs to queue the connections because the server is not able to process them. And even on the 15 milliseconds, I think most of the medium complexity components take like 15 milliseconds to render. It's like it's able to handle more than 5 times the requests, and the median is almost 10 times faster. Like it's impressive. And this is like a chart showing that it scales quite well if we change to worker threads, if we are required to use Node. And this is a conclusion, like, well, Node.js works with worker threads, works well. Of course, this is not free. We need to add more CPUs. Like, instead of having the slim pod with 1 CPU, we need to have a pod with 2, 3, or 4 CPUs. And one thing that the memory stays low thanks to streaming. I tested this before using streaming, and the memory consumption was a bit lower, like almost double the usage. And the thing is, like, this is no silver bullet. Like you can go to my GitHub, copy the code, and test on your use case, but please test it first. Like, don't take my word for granted. Yeah. And thank you. Question. And at OLX, we currently were hiring for front-end, the senior front-end engineer and staff engineer for remote. Like, if any of you is interested, you can talk to me. Sim.
So you said something about blocking the React component rendering, right?
Yeah.
I'm wondering, how did you block it, like IO bound or something bound?
I blocked it CPU bound because usually in Node.js, if we use sync APIs, that's the thing. Like we can. Sorry, I need to repeat the question. The question was the blocking I used for the. What kind of blocking I used for the React component was CPU bound or IO bound. I used CPU bound. It's just a while that generates random numbers and waits until the data has passed. I could use the IO bound API that was blocking would do the same thing, and that's what I did because I want to simulate complex trees, and complex trees usually consume a lot of CPU. Let me just add to this. One issue with the worker thread, and something that I forgot to add, is that if we have a lot of connections, it does not, up until to a point, it stops scaling because it is bound to the number of connections the operating system supports. So at that time, we probably need to create a new pod or use something, a different approach. Any other question?
guess I can do it. Did you completely override Next.js process of doing server-side rendering, or did you take anything from it? Like, did you just change some parts? I didn't understand that.
No, what I did, so the question was, did I rewrite the server-side rendering of Next.js? Did I override something? Yeah, I just override the output. Like in Next.js, there are some APIs. Let me go. Yeah, they have multiple APIs. This is one of them. This app is Next.js, and we have the render method. And in here, we send a request and response. And internally, Next.js does, it's just, and what it expects for these request and response are HTTP request and responses objects. It accepts streams, it accepts quite a number of things. And Next.js writes directly into the response there. And what I did, that's why I used the proxy. I just hooked the response to be able to pick up what Next.js was writing to that dummy response and then send that to the main thread.
Yeah, right.
Thank you for the question.
Why did you use the Fastify if you could overwrite the response directly?
Can you repeat? Why did I?
So you used Fastify, right?
Yes.
Like an HTTP handler for
Yeah.
Node.js. Did you need it to overwrite the response?
So
to use server-side?
No. The question was, why did I use Fastify? Do I need to override? No, it's because internally at OLX we're using Fastify, and I'm kind of used to it. And Fastify, in some things, are a bit faster than Express, and I went for it. I could do it Express. They have the same. It's a bit different, but they kind of have the same HTTP response API, and even if I used Express or even the vanilla HTTP server inside Node, I wouldn't have to use the proxy to override it in the same way. Yeah.
Can I ask more questions?
Yes.
So
Please.
is this live in production at OLX? That's the first question. And then the second question is, due to how you implemented this is not Next.js upstream proof. So it feels like this should be like a library that you more or less try to maintain up to date, or even better, part of Next.js, right?
Yeah. The first question was, are we using this live at OLX? And the straight answer is no. Right now we are kind of trying to improve things internally. It's something that we might look after, but it's something right now we are not using. We're just looking for different answers. And the second question was...
how it's implemented.
Yeah.
It's not upstream proof, like
Yeah.
Next.js.
Yeah. The second question was like this is custom implemented, so it's not tied to any public API of Next.js.
Are you going to make a library?
And the question was, am I going to make a library? And right now, it's something that I thought of and probably will do in open source, because I did it on my free time, even though I'm working at OLX. I'm just trying to find answers. And probably I can do a plugin to Fastify, because it's what I'm using. Yeah. Any more questions? Thank you.